Chapter 6 of the linear programming module is on linear programming, and the first part of that is forming a linear programming problem. There's really two parts to linear programming: forming problems and solving problems. You could get asked both of those in the exam as separate questions. You could be asked one and not the other, or you could be given a combined question that uses both. But this part is just looking at forming a problem. Now there are three parts to it, and you must remember this. First thing you must always do is define the variables. What do the variables actually mean in the context of the problem? Secondly, state the objective. Now the objective is always given in the question, but you must always include a formula. And then write down the constraints. And these will be as inequalities. Try to remember the non-negative ones. Normally it's x is bigger than 0, y is bigger than 0, it might be greater than or equal to, but it's an easy one to forget. It can be a mark in the exam. So let's look at example 1. Example 1 says, Mrs. Cook is making a cake to sell for charity. She makes two types of cakes, a fruit cake and a chocolate cake. Amongst the ingredients, each fruit cake requires 1 egg, 250 grams of flour, 200 grams of sugar. The chocolate cake requires 2 eggs, 250 grams of flour, 300 grams of sugar. Then tells us that she's got 36 eggs, 7 kilo of flour, 6 kilo of sugar. She sells the fruit cakes for £3.50, chocolate cakes for £5, and she wants to maximise the money she makes from the sales. Okay, so firstly, it's a lot of information. So we're going to take the information and put it into a table. So it says she's got 2 types of cake, so it's a fruit cake and a chocolate cake. And then it tells us about the ingredients. So part of the ingredients include eggs, flour, sugar. We'll fill that in. It says the fruit cake needs 1 egg, 250 grams of flour, 200 grams of sugar, and the chocolate one needs 2 eggs, 250 flour, 300 sugar. You can put in the last one either max or total, wherever's appropriate. We've got a maximum of 36 eggs. We've got 7 kilo of flour, so that's 700 grams of flour. You need to make sure the units are consistent. 6 kilo of sugar. So for example, you could in theory make 36 fruit cakes. You'd have enough eggs anyway to make 36 fruit cakes. But 36 times 250 is going to be bigger than 7,000, so you wouldn't actually have enough. You'd run out of flour first. Okay, right, what else are you told? How much she sells them for. So she sells the fruit cake for £3.50, chocolate cake for £5, and she wants to maximise the money. Okay, so let's go through this then. It's a good idea with the linear programming problems to do it in rough first and then write your solution down neatly afterwards. So, to find the variables, so we're going to say x is the number of fruit cakes she makes, y is the number of chocolate cakes she makes. The objective is to maximise the money she makes. Let's maximise pounds. Maximise pounds, sales, say S, where S equals. Now she makes £3.50 for every fruit cake. So remember the fruit cake is X. £5 for every chocolate cake. So I'm going to need to work out the total she makes. It's going to be £3.50 times the number of fruit cakes times X, plus 5 times the number of chocolate cakes, so times Y. So that's going to be 3.5x plus 5y. Okay, then the constraints. Now these are what gives you the constraints. The constraints are the constraint is how many cakes can you actually make. So in order to maximise a profit, you just want to probably make the maximum number of cakes you can with the ingredients she has. So you're going to get a constraint from the eggs, because she's only got 36 eggs, similar one for flour and for sugar. So how much eggs will she make? How much eggs is she going to use? Well, she's going to use 1x, or just x, plus 2y eggs. And that has to be less than or equal to 36. Okay, you should always try to simplify the inequalities, but there'll be nothing to simplify on that one. From the flour would have 250x plus 250y, because it's 250 times the number of fruit cakes plus 250 times the number of chocolate cakes. It must be less than or equal to 7,000. If we divide that, well, firstly, if we divide that by 10, and if we divide that by 25, we're going to have x plus y must be less than or equal to, I think it's 28. And the one for the sugar, you'd have 200x plus 300y. 200 times x plus 300 times y gives you the total amount of sugar from all the cakes that she makes. That must be less than or equal to 6,000. If we divide it all by 100, we get 2x plus 3y. Must be less than or equal to 60. So those would be the constraints. So you'd write subject to, don't forget the non-negative one, x comma y is greater than or equal to 0. You can't make a negative amount of cakes, that would be weird. We've got x plus 2y is less than or equal to 36, x plus y is less than or equal to 28, and 2x plus 3y is less than or equal to 60. Okay, so now on to example 2. It says a company buys 2 types of diary to send to its customers, a desktop diary and a pocket diary. So desk and pocket. They'll need to place a minimum order of 200 desktops. So minimum 200 desktops and 80 pocket diaries. They will need twice as many pocket diaries as desktop diaries. We'll come back to that later. We'll need a total of at least 400 diaries. Okay. So minimum, if we call this one total, total must be at least 400. It says each desktop diary costs £6. Each pocket diary costs £3. And we're trying to minimise the cost. Okay, so that's all we really need in our table. So let's call the desktop X, pocket diary Y. The objective would be to minimise the cost, where the cost is going to be 6x plus 3y. Let's look at the constraints though. So constraints that we're going to have is x must be greater than or equal to 100, y must be greater than or equal to 80, and the total, which would be x plus y, must be greater than or equal to 400. So there's no need in this question to give the non-negative clause, because you already know x and y are bigger than 280 respectively, so they're definitely bigger than 0. It's this sentence what says they will need at least twice as many pocket diaries as desktop. Now these statements like that cause a lot of problems. So pocket diaries are y, desk diaries are x, at least twice as many. So the most intuitive thing to do is to write 2y must be bigger than or equal to x. And that's what a lot of students would write. But unfortunately that's wrong. Now, the way I'd recommend to deal with questions like this, or parts of the question like this, where it's talking about twice as many, 3 times as many, at least half, at most half, but anything like that, is to put some numbers in. So say, for example, we went for the at least twice as many pocket diaries as desktop diaries. So say if we went for the minimum desktop, so we got desk, which is x, pocket, which is Y. And we went for the minimum number of desktops. Now it says we need twice as many pocket diaries. So let's imagine it's exactly that. Not forget about the at least for now. Let's imagine you need exactly twice as many pocket diaries as desktop diaries. So you'd actually need 400 pocket diaries, which makes the nonsense of this being 80, because actually the minimum is 400. And actually the minimum here, you can't do less than 600. All right, then. Now try to create that into an equation. So if you make that into an equation, you'd have to double this side, because 2 times 200, 400 equals 400. So it's actually the x that doubles, not the y. It's counterintuitive. It's the opposite to what you probably think. And then if we bring the at least back in, it said, just checking, at least twice as many pocket diaries. At least twice as many pocket diaries. So that one's the one that can get bigger. So it's going to be less than or equal to, because this is the one that can be bigger. This is x, so it's 2 times x. This is y. So it's 2x is less than or equal to y. So very much different to that. So let's put all that together then into our linear programming problem. So I'm going to say x is the number of desktop diaries, y is the number of pocket diaries, so we've defined the variables, state the objective. We want to minimise cost, which we'll call C, where C equals 6x plus 3y. I've got the 3. Subject to, we don't need the non-negative one this time. X is greater than or equal to 200. Now, I said earlier y must be 400, but put 80. Y must be greater than or equal to 80. The total, x plus y, must be greater than 400. And then we had the other clause from here that I would always write in terms of y. Look, it's pointing to the 2x. Y is bigger than or equal to 2x. It just makes it easier if you're doing it like that for when you come to solving it. So example 3. We're told that a company produces 2 types of syrup, syrup A and syrup B. And each syrup contains sugar, fruit and juice. No, syrups are a blend of sugar, fruit and juice. Okay, so syrup A contains 30% sugar, 50% fruit, 20% juice. B contains 20% sugar, 35% fruit, 45% juice. Each litre of syrup A costs 50p. Each litre of syrup B costs 40p. There is a maximum daily production of 40,000 litres of A. So the most we can make is 40,000 of A. The most we can make of B is 40,000 litres of syrup B in a day. The confectionery manufacturer placed an order for 60,000 litres of syrup, so we need to make at least 60,000, but requires below 25% sugar, at least 40% fruit, no more than 35% juice. The company blends syrup A and B to meet the manufacturer's needs. So it uses a combination of A and B to meet those constraints. We want to minimise costs. This one actually, and it's quite common in the exam to do this, actually gives us, it defines the variables for us. So it says X is the number of litres of syrup A, Y is the number of litres of syrup B. So there's no point doing that when you write out the problem, because it's already given for you. Okay, so in the constraints, we're told it must be below 25% sugar. It must be at least 40% fruit. It must be no more than 35% juice. So you've got a difference there between below and no more than. So no more than means it could be equal, whereas below means it must be less. Okay, so let's think about the objective first. The objective is going to be 50 lots of x. I mean, it could have used a and b rather than x and y, but 50 lots of x plus 40 lots of y. But when you're making like 40,000 lots of it, it's going to be daft to use pence. So we're going to be better off calling it 0.5 and 0.4. So the cost is going to be given by 0.5x plus 0.4y, where C is in pounds. Now let's look at these constraints. So sugar. So the amount of sugar is going to be 30% of x plus 20% of y. So to work out 30% of something, you just times it by 0.30 or 0.3. So we'd have 0.3x plus 0.2y must be less than 25% of the total. So your total blend, less than 25% of it must be the sugar, and this is given the sugar. The sugar must be less than 25% of the blend of the total. Well, what is the total? The total is simply x plus y. How much of syrup A you use, how much of syrup B you use. So 25% of that would be 0.25x plus 0.25y. Bringing that across, that would be 0.05x. If you think of that as 0.30, take away 0.25 is 0.05. Bringing that across, 0.25, take away 0.20, 0.05. If you then times that by 20, you get x is less than y. So in order to make sure that you have less than 25% sugar in your blend, you must make sure you put in more of syrup B than syrup A. And that kind of makes sense because it's 30, 20 and 25 is in the middle. So you need to use more of the 20% to make sure the average is less than 25%. So that's one constraint. Let's go on to this one. So we've got 0.5x, 50% of I, plus 0.35y, 35% of syrup B. That's the total amount of syrup in your blend. That must be at least 40% of the total. So 0.4x plus y. So 0.4x, 0.4y. So if we bring the 0.4x over, 0.5 take away 0.4 is 0.1. Bring the 0.35 over, 0.40y take away 0.35y is 0.05y. Okay, and if we times that by 20, we're going to get 2x is greater than or equal to y, or y is less than or equal to 2x as our second constraint. Doing something similar for the juice, we've got 0.2x, 20% of x, plus 0.45y, because 45% of blend B is going to be juice. So that's your total juice. That must be less than or equal to 35% of the total. So 0.35x, 0.35y. This time, if we bring the x over here, 0.35 take away 0.20 is 0.15. We'll bring this one over here, 0.45y take away 0.35y, it's 0.10y or 0.1y. And then if we times that by 20 again, we're going to get 2y is less than or equal to 3x. We're going to need the non-negative one for this one. We can't make a negative amount of juice. We're also told in the question, a manufacturer placed an order for 60,000 litres of syrup. So we know x plus y must be bigger than or equal to 60,000. You've got to make at least 60,000 litres in order to fill the order. So let's put that all together in a program, and in a linear programming problem. We don't need to define the variables because it's given in the question. So the objective is to minimise cost C in pounds, where C equals 0.25x plus 0.4y. Subject to x comma y is bigger than 0, x plus y is bigger than 60,000, x is less than y from the sugar, y is less than or equal to 2x from the fruit, and 2y is less than or equal to 3x from the juice. In that one I'd actually write as y is bigger than x, so you've got y in front of all of them. Okay, that's all the examples on the first part of this chapter, so if you have a go now at exercise 6a.